Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here at Loudon Elementary, home of the Leopards for the Science for Kern Engineering Challenge, and we're here to do the math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And in studio with us today we have Elizabeth. And Elizabeth, if somebody wanted to get a hold of us, what would they need to do?
Call in Bakersfield 636-4357 for math homework help and toll free 1-866-636-6284. Our email is dothemath@kern.org and we're online at dothemathonline.net. And on social media, we are on Facebook, Instagram, Twitter, and YouTube.
That's a mouthful, isn't it? But you got it all out perfectly. While you're here right now, why don't you let everybody know where you go to school and what grade you're in?
I'm in 6th grade, and I go to Buena Vista Elementary.
And how long have you been a Bulldog?
Since 2nd grade.
Everything going pretty well out there? If you could modify one thing at your school, where you could change it, or you could eliminate it, or you could add something brand new, what would it be?
I would add more sports for everybody and make more after-school help.
Okay, so do you participate in any of the sports and things like that right now? What are you participating in?
I participate in flag football.
Okay, and you guys do that during lunch recess, or is that after school?
It's after school.
Okay, and has that season started, or is it kind of ending, or?
It ended already.
And how'd you guys do?
We won all of our games.
You won every game. That's pretty good right there. How's 6th grade going overall?
Perfect.
Perfect. All right. Well, young lady, over to the board. Let's see how perfect everything is going here.
There we go.
So we have a Halloween problem. Is it ever too early to start talking about Halloween this week?
No.
All right, so here we go. Elizabeth wants to be a princess for Halloween. I just threw that in there. You know how I do. Okay. When she gets to the store, she realizes there are many options. There are 5 different crowns, 8 different dresses, and 3 different pairs of shoes. We want to know how many possible combinations there are if you have 1 crown, 1 dress, and 1 set of shoes. So do you have any idea how to figure out combinations? All right, so explain, Scott, how you want to solve this problem.
I'm thinking of doing all crowns, putting crown, 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 and then just changing up the different
You can change each one. So you maybe want to start with a little picture or something like that? Okay, so give us an idea of what's going on in your head about how you're understanding the problem, and then go ahead and draw a little picture or whatever you got going on, like you said, crown, crown, crown. And you can either draw the crown or you can, there you go, there's one. Yeah. So the idea here is that we can choose from any of the 5, right? You got 5 choices there. And then you have even more choices. So what are you going to do for those dresses? Hey, there you go. It's a pretty good dress. Right? You could also just write a D for dress if you don't want to draw a bunch of dresses, but I like it. All right? And we got some shoes. You going to draw some shoes as well? Are these going to be sneakers? Are they going to have high heels or what? Oh, there we go. All right. Pair of shoes. Yay! I like it. Okay, so we got crowns and dresses and shoes, and the idea is we could mix this crown with this dress and these shoes, or this crown with this dress and these shoes, or this crown and this dress and these shoes, or let's say you got another dress over here, right? I'm not very good at drawing dresses. I know you're much better than I am. So if you had some D's here, right? You could have this crown and this dress and these shoes, and this, or this crown and this dress and these shoes, or you could have another pair of shoes. Oh, so many options. We want to know how many different outfits could you have, and as soon as you change your shoes, or change your crown or change your dress, you're going to have a different outfit, right? So what about the math part of this problem? How are we going to do the math here? We have 5 crowns, so you know we're going to do probably something with the 5, the 8, and the 3. What do you want to do with those?
I'm thinking taking the 5 and going 1 combination, 2 combination, 3 combination. On.
Yeah,
So
definitely would work. I'm thinking that might take quite a while though. Maybe even longer than we have show. So if you started to do all the combinations and then at the end you added them all up, you could find out how many you had, right? So what is a shorter form of doing addition? If you're doing a bunch of addition over and over and over again, multiplication. Which numbers do you want to multiply?
maybe the 5 times the 8 and then times the 3.
There you go. 5 times the 8 times the 3. That's going to give us a pretty big number, but we know there's a lot of different combinations. Let's give it a try. Oh, I like that. Okay. So we got to do 15 times 8 now. $120. Tell me a little bit about, because I'm really curious to know when students do things differently than maybe I would or someone else would. Why did you choose to multiply 5 times 3 first?
Because that's going to equal the smallest number that we have.
Okay, and you like to work with that smallest number. Yeah, there you go. What would happen? Would you get the same answer if you did 5 times 8 first?
Yeah.
What's 5 times 8?
40.
40, okay. And 40 times 3?
120.
Strangely enough, we have the same answer. That's exactly right. Yeah, so it's nice that you can do it in any order. Any idea what that's called in multiplication? You can mix up the order, it doesn't really matter. There's all kinds of properties in math. And we could call that the commutative property because you could move them around and be able to do that, do it a different way. But the answer is the same. 120, we have 120 what?
120 different combinations.
Different combinations. Well done. I like how you did that problem.
There you go.
Good job.
Nicely done. First problem of the day. 636-4357 is that phone number. We do have phone tutors available on most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, today's Math in the News. Elizabeth already said that it's not too early to start talking about Halloween, and especially Halloween candy. Out of that photo that's on the screen right now, do you have a favorite out of what you can see?
Smarties.
You like the Smarties? The best? Do you have a favorite other than the Smarties? Like something that's not on there?
Probably,
Like if you could go, hey, give this out for Halloween and I'm going to come to your house every 5 minutes, what would you like them to give out?
Crunch bars.
Ooh, Nestle Crunch Bars, there you go, all right? So anyway, we're going to talk a little bit about Halloween candy right now, okay? So you know what a poll is, right? You go out and you ask people, hey, what do you think of this? What do you think of that, right? So according to a poll, more than 36% of Americans say Reese's Peanut Butter Cups are their favorite Halloween treat. It's more than twice the number of people who chose Snickers as their favorite. M&M's came in third, and then candy corn and all the other things are coming down at the end. So we can see Reese's Peanut Butter Cups is at 36%. Snickers is 18, M&M's 11, Hershey Bar is 6. And I would say that we would put that Crunch Bar probably in there with that 6%, with that Hershey Bar right there. Candy corn. Now that's a big thing. I remember when I was young and we'd go out and you would get a bunch of candy corn, right? And candy corn, you either like it or you don't. It's one of those things.
Yeah, it's
okay.
not, it's
Do
a
you
don't
like
for
candy
me.
corn?
Candy corn is
See,
pretty
you like
good.
candy. It seems like there are a lot of kids today, they like candy corn. Kiki, do you like candy corn? Oh, yeah. See, Kiki's a high school student. She likes candy corn.
All right.
Scott, you like it?
Not so much.
I don't desire it myself
not my
either.
thing.
I just assume they eliminate candy corn from everything in it. But you know what? I
Doesn't
can
need to be
understand that a lot of hey, get the buzzer on that. That's fine. But we got a mixed group here, so half like it, half don't.
That's right.
So anyway, we see a lot of math in here, right? Now, what I'm going to need you to do is I'm going to need you to do a little bit of math. So here it is. The poll was conducted by the Institute over the telephone, all right? They had 1,161 adults in the United States answer this. How many people said Reese's was their favorite? Now, we know what percent said Reese's was their favorite. Do you remember?
We said 36.
36%, right? But we need to know what 36% of 1,161 is. Do you have any idea how we could figure that out?
We can divide 1,161 divided by 36.
Well, there's a lot of different ways we could do this. So Scott's going to introduce you to the is over of concept here, okay? So head on over to the board and we'll go ahead and work on this one right now. 36% of 1,161.
So this is the main question we're looking at, right? Really, this is the question we would ask in regular everyday language, even though if we knew how to do the math or not. What is 36% of 1,161? That's what we want to know, okay? All right, so this is my favorite way of doing percentage problems because it doesn't matter which part you're missing, okay? Here's what I mean by that. You can see that we have something that goes with the is. The is referring to the what, right? This is the question mark. In our case, we're going to put a letter there. What's your favorite letter?
E.
E. I almost could have predicted that. I like it. Okay, then we have a percent, okay? And then we have a number that goes with the of. This number is referring to the 1,161. It's next to the word of, okay? And the reason that's important is because if you can remember this simple ratio, the ratio goes like this. Is over of equals percent over 100. And you can solve any percentage problem, any of them, using this ratio, okay? Whether the is number is missing, or the percent number is missing, or the of number is missing, you can always solve it like this. So here's how we start. Ready? We're going to be able to set up a ratio like this, okay?
I think I know how to do this.
Do you? I'm going to put in 100, and you can start filling in the other spots. So the percent is 36. Do you have to do anything to the 36 at all?
Not yet.
Not yet. Okay. Another reason I like this a lot, you don't have to change it to a decimal or anything. So the of number 1,161. That's right. And what
Then
goes in the
you have to
top?
multiply those two.
Mm-hmm.
We
What
don't
goes
know
in the
this
top
number
one there?
yet.
What is it?
We don't know it yet.
We don't. What are you going to put there instead?
E.
An E. Yes, I like it.
So to help you out, Elizabeth, I'm going to give you a calculator.
Hey.
All right, so
I don't
that
know
way
what's
you don't have
happening.
to do it off on the side. Just use the calculator, use tools that you have. But explain to Scott what you're doing also.
I have to multiply 1,161 times 36.
And what do we get?
4,107.96.
So 41796. Wow. Tell me what that number is.
41,796.
Gotcha. All right. Good. Are we done?
No, we have to divide this by 100.
I like it. Yeah, there you go. So I wasn't crossing off the equal sign here. What I like to do is put here
Cross
to make
multiply.
Yeah, do a little cross multiplication. So we multiply these two, right? The ones that are on opposite ends of these sticks. Now we're going to multiply these two, so this number equals 100 times E. Go ahead and finish that up. I'll give you a little more room here. What do we do next? How would you show this, the last part of this equation? Because really what we have is an equation, right? 100 times some number is this number here.
I would do 41,796 divided by 100.
All right. Okay. So 41796?
Yes.
Oh, look at that, the same numbers. Same exact numbers?
Where's the decimal point?
Ah, where's the decimal point? That's what we need to know, right? There it is right there. So when you divide by 10, you'd move the decimal point back one place. You divide by 100, you move it back two places. So this number, can you tell me what this number is? 417.96? What is that?
417 and 96 tenths. No, hundredths.
Hundreds. How in the world can you have a poll and 96 hundredths of a person likes Reese's? That's crazy. That's crazy, right? You don't have 96 hundredths of a person. So how many people do you think liked Reese's in this survey?
418.
There you go. Rounded it up nicely. Oh, well done. 418 people with pretty good taste. And if you go back to that picture, I know I saw one person got a little head start on that candy picture because there was one of those Reese's that was already open. So it
Well,
must
let's
be the
go
most
ahead.
popular. Did you see this one over here? Look at that. That one looks like it's
over
half
here on
eaten
the right
there.
side.
Somebody got a head start on that one.
You got to eat as you go around and collect.
That's right.
But anyway, that is today's Math in the News. Nicely done with that, Elizabeth. We do have phone tutors available until 5:30 this afternoon, and right now we're going to find out what the latest challenge was with Science for Kern and the students at Loudon Elementary.
Today we are at Loudon Elementary, home of the Leopards, and I am with Michelle Roy for Science for Kern and Engineering.
And engineering, the Science for Kern Engineering Challenge. today.
Okay, so last month, can you kind of recap what they did last month?
Last month, we built earthquake structures.
Ooh.
And I had to think for a second. We built earthquake-safe structures, and we had a device on which we tested earthquakes to see if the structures would collapse or not.
Which was really cool because we happened to have
Correct.
just a couple this past summer.
Right, it was a super timely topic. And, yeah.
So what are we going to be doing today?
Today we're going to be engineering with just some super simple materials, straws and some masking tape. The constraints today are, thank you, a bag of 50 just regular plastic drinking straws, and we've measured out 1 meter of tape, and we've strategically placed it on the edge of the table so that the tape doesn't roll up on itself. And prior to going on camera, actually, we spent a little bit of time building what we were calling fishing poles to see how we could get the straws to attach to one another and to start discovering some of the better building properties of how best to put straws together for strength in terms of going up.
So the overall objective.
Our challenge for today is to use, they can only use the 50 straws, and to go as tall as possible and freestanding before the end of the show.
So no weight is going to be put on it or
No.
anything, so they're just building
Just
a
going
structure.
as tall as possible.
Wow. With two simple materials.
Very,
Tape
yep.
and
tape
straws.
And straws. And it does have to be freestanding. They can't tape to the table.
Okay, I'll let you take it away.
All right. So are you ready, ladies and gentlemen? Yeah! All right. Let's start building, and we'll come around and start talking to you about strategy.
I got a great idea. Since you said we can't go on this beach, let's do on this desk because Natalia's desk basically.
All right. So what is your plan? What are you thinking about doing?
We're thinking about making a base.
Okay, and what might that base look like?
Kind of like a square or a rectangle.
Okay, and why do you think it's important to start with a base?
Because if it's just straight, it's just gonna fall. Straws in the middle. Yeah.
As in, demonstrate what you mean by straight.
It's like that. Yeah, if it's like this, it might as well just fall.
Okay. And so what shape base do you think you're going to work from?
Maybe a rectangle or a square.
Okay. And how will you get your straws to stay together?
We're gonna put tape around. I'm thinking of just like. Let's use all straws. No, just some. No, this is. They're ready to time, and we're going to bake the pasta. This is the only tape we're going to use. Tape across it, so I can keep it shaped, and then we'll start putting the stuff up.
Okay. Well, we'll come back and check on you once it starts to go up. So, hello, ladies. Tell us about what you about your plan.
I'm thinking about doing 4 straws, like probably like this, like a little star, like a little X. And we're doing like 2 or 4 straws, doing like that. We're gonna keep on building it up, and then probably gonna do stuff standing right here for it to like. So like it's the base, so it can like stand.
All right. So you think that you need a base first.
Yes.
All right. What if you don't have a base?
We'll have a plan B.
All right. So tell us about your plan.
Well, our plan is going to be about putting them and like sticking them like all the way in, so it would hold much better. And we figured out that we would add like 2 more. We would add like 9 straws, see if it won't really bend that much.
Okay, so if you're so your plan then is to just go straight up?
Yeah.
All right, but if it has to be freestanding means that I let it go. How are you going to get it to stand up without taping it to the table? Think about that, right?
We'll try to balance it by like using other straws.
Oh, okay. Maybe you're getting somewhere with that. We're going to let you work on that. All right, who's next over here? Tell us a little bit about what. Oh, wow. Tell me about this.
That was you.
So this is going to be our bottom since you said we can't like tape it to the surface.
Okay.
So we're doing this as our bottom and then we're going to get the straws and just tape them to there and we're just going to connect it
All
and
right.
start making it.
To go up. All right. So what do you have going here, ladies? Oh, we can't cut. No, no cutting. So and it has to be freestanding, meaning that you're using the desks to hold it up?
Yeah.
Can't do that either. So check this out. So if we just put it, and this is legal, but if we put our straw tower here, it's going to fall over, right?
So a couple things I noticed. A lot of them are quickly trying to get bases.
Right.
Has to be freestanding, no tape. You can't tape it, and there's no cutting of straws, right?
Correct.
Okay, well, we're going to keep on letting them work.
Yep.
And we're going to send it back to the studio, but when we come back, I'm sure there'll be more of the structures built.
Right.
So back to you at the studio.
All right, thanks for that, Mary Lou and Michelle, and the kids from Loudon Elementary working with Science for Kern. In studio, we have Elizabeth, a 6th grade student, and did some great work with percentages before and Halloween candy. However, now it is time to get down to the real work that you need to do. You all ready?
Yep.
All right, over to the board, young lady. 12 minus 7, open parentheses, n minus 4, close parentheses, plus n equals -2. So Elizabeth, if you could step by step explain to Scott how to solve this equation.
A lot of stuff going on in this one.
First I need to multiply -7 times n.
Okay.
So I would have to go -7n.
Okay.
And then I would have to do -7 times -4, which is +28.
Wonderful work, and you're doing this distributed properly. I'm so glad, 2 things. First of all, that you kept the negative when you're multiplying times those 2 numbers. And secondly, that you didn't go automatically and go, oh, 12 minus 7, I can do that. That's a really tempting thing to do, but you did exactly right, which is the multiplication first. Good. What else? What happens to the 12? Where does that go?
We have to bring it down as well.
Okay. Still okay. That's still there. That's right.
And we have to bring down the n.
Okay. So you basically rewritten the equation with no parentheses, and that makes it much more simple. Okay, what's next?
Then we have to add all of our numbers together
Okay.
to make it easier. So we would do -7 plus n, which would be -7n.
So we had -7n, and we're going to add how many n's here?
1.
Think about this. There's a 1 there, right? And think about your signs. So you have -7
-8n.
plus 1. Again, think about that a little bit more, right? -7 plus 1. And that's one that tends to...
-6.
Ah, there you go. -6, yeah. Because you're really going to subtract those 2 numbers. I like it.
And 40 equals -2.
Ah, where'd the 40 come from?
The 40, you have to add 28 and 12.
Right, okay, gotcha. So we put these 2 together, right? You put those 2 together, and
we
you
put
put
those
those 2
together.
together. They went right there. Okay, good. So things are getting much more simple now. We had a bunch of terms at the top, and now we're down to 1, 2, 3 terms left. All right, what's next?
We have to get rid of the 40.
Okay. And what you do to one side of the equation, you got to do the other side, right? So that's why I did it on both sides. I like that. So we still have the -6n, right? Good. And here's the key. Let's make sure it's right. Oh, you added them together. Good job. Well done. They're both negatives, and we're going to add them together. Give you a little more room to finish up.
And then you have to get rid of the 6 and n. So you would divide -6n by -6.
Good.
which means n equals positive 7.
And what a wonderful choice you made here, because you saw the negative and the negative. You put the positive in there before you even mess with the numbers, and I always suggest that. Put the sign in first, then at the end of the problem you don't have to remember, was it positive, was it negative? You already know it because you put the sign in first. Great job. How would you know for sure? If you had to bet money that 7 was the answer, how would you know and be able to maybe check the answer?
Well, I would do, for n, I would put that here this would be 7.
Okay.
So I would do that to every single one.
Gotcha. Is there anywhere else you could do it? Could you do it? Could you put it into this end and make it work?
I could.
In this part right here? You could put it in this end right here, right? What about the very, very beginning? Could you go way back to the beginning and put a 7 in there and make sure it works? Let's do that. Okay, so here we go. Here's the problem we're really looking at. 12 minus 7 times 7 minus 4 plus 7, right?
Yeah.
Equals negative 2. And we're going to put a question mark there because I'm not quite sure if it does equal, but if it does, we'll be sure what to find out. Okay, so if you were doing a problem like this, right, and basically we might even say, you know what, we're not even going to know what it equals. Let's find out what it equals. If you're going to do a problem like this, what would you do first in there?
First, I would get rid of the parentheses.
Okay.
So negative 7 times 7, which would be negative 49. And then I would do negative 7 times negative 4, which would be positive 28.
Gotcha. So you did some distributed property here. I like that. Could you also just do 7 minus 4 in the parentheses?
No.
Why not?
You could.
You could, right? Nothing wrong with what you've done. What you've done is wonderful work. We couldn't do that up here because we didn't have a value for n initially. But now that we do, you could simplify the other way. But I like the way you're doing it. I'll put the 12 out in front here, and we have something else left. We got a plus 7 there too. Okay, so let's see if we can simplify this even more. What are you going to put together next?
I would put together the 12, the 28, and the 7.
And why did you choose all those numbers?
Because those are all positives.
Okay, so we're going to see what the positive team scored here. All right. 10 and 7 more, 17, good.
47.
So this is a positive 47, and that's a negative 49. If you put those two together,
You have to subtract 47 minus 49, and then you get negative 2.
look at that. So it's a wonderful check you made there. So after all that work, and then a little bit more work to make sure it works, then we know for sure that's the answer. Nice job.
There you go, nicely done. So equations, I knew you had some familiarity with those, and that way it's always good to check the answer. That way you know on a test whether or not you have that answer correct. We do have phone tutors available until 5:30 this afternoon for some great work by Elizabeth right there. We're going to award her with a couple of tickets to any athletic event courtesy of CSCB Athletics. So congratulations on that, and we'll be back with more right after this. Today we're at Frazier Park Elementary School, home of the Bobcats, and we're here to
Do the math!
All right, we've got some fourth grade students at Frazier Park Elementary School, and we've been playing some games where you're starting to think about multiples and working at a game where you don't want to be the person to take the last one. Same thing with this, but instead of going backwards, we're going to count up. All right? So we're going to start obviously at 0, and we're going to work our way up to 21. You do not want to be the person to land on 21. Okay? Now, in other games, we played it where you could take 1, 2, 3, or 4 numbers off the board.
Yeah.
Now, you can only take 1, 2, or 3. All right? So, if I was going to go first, I would go 1 and 2. I could have gone 3 if I wanted to, okay? But you don't want to be the person to land on 21. You got the idea now?
Yeah.
So it's a little different, okay? So now, go ahead and start the game. You may only add 1, 2, or 3 at a time. You do not want to land on 21. All right? So now you may add 1, 2, or 3 numbers. So you can either go 3, 4, 5, or just 3, or 3, 4.
Oh, you went 1 and 2?
So you want to go 3, 4, 5? Or just 3?
3.
So you're just going to add 2? All right, so now I will go and I will add 5, 6, 7. All right, so we're about halfway there. We're at 10. Now let's see, I will go with 11 and 12. Remember, you do not want to land on 21. So 13, I'll go 14, 15. So Jordan's got 16, 17. I will go 18. Good, you went both of them, right? You took 19 and 20, so that way I get stuck having to put the number 21. All right? How did you guys do down there? Are you through yet, or you almost? Oh, he's going 18, 19, and 20. So he got stuck with the 21 again, huh? How did you girls do over here?
So I didn't really remember, so I got stuck with 19, then I went to 20, then I remembered I can't get to 21, so I said I gave the pencil to her and she did 21.
So you had 3 spots left, and you almost forgot that you can just do 2?
Yeah.
All right, so you guys like the idea of that game where you go up a little bit now?
Yeah.
Now, what could you do to make sure that you always win? Because we're only going to 21, right? We didn't have to start at 56 like before.
Multiples of 7?
Multiples of 7, right?
7 times 3.
So 7 and 3, right? So you want to think about 3s and 7s as you're doing this, because you don't want to end up on the 21. You guys like that one?
Yeah.
All right, there we go. One more activity, counting up, with the 4th grade students at Frazier Park Elementary School. Once again, big thanks to the staff and students at Frazier Park Elementary School. We do have phone tutors available until 5:30, but we also have an opportunity right now to head out back to Loudon Elementary, see how the kids are doing with Science for Kern.
We are back at Loudon Elementary, and I'm with Michelle Roy, Science for Kern and Engineering. How are you doing today?
We're doing great. You know, we are learning an awful lot about the importance of a base
Yes.
to a structure and how critical that is.
Now we've made some groups have made progress, and let's kind of go around and see what they've been doing.
That sounds great. We have some really interesting designs.
Yes, we do.
All right, so tell us a little bit about where you are now. Can we see your structure? Let's see how tall you've gone. Because I'll be comparing you. So how many inches is that?
It is 12. It is 12.
Sure?
It is at 12.
Look at that. Look at that again.
Because on here it's on 15, but here it's like on 12.
Oh, that's 21.
Oh,
On this
here
side
21.
from 0. So that's how many?
That's 15 inches wide.
Right? So, will your building stand? Will your tower stand up if you let it go? Let's test it.
Right,
Hands
leave it.
off. Let's see what happens when you take your hands off. All right. So,
Oh, it's because like it's leaning.
all right. So, what do you think you can do? What part do you think you need to change so that it will stand?
It's because like the tape is like in there, so it's like like in there, so from putting it in.
Okay.
Maybe we should like spread it out more.
Yeah.
Spread out what?
Like the straws, like I think they're too close around.
Well, I'm wondering what would happen if maybe you designed a piece that maybe served the purpose of keeping it from squishing in as it stands there. So, what do you think you might be able to do to solve that problem?
I think we only have one option, and that's sticking one more.
So what do you mean by that?
Like we should tape one from here, because sometimes it might leave from here.
Another one to the side,
Yeah.
or
This one?
what about if you went this way in there? Just do you think that would change? Judy, there's a way. I want to challenge you to think about this. Is there a way to put a straw this way that might keep it from closing up? And we're going to let you work on that and we'll come back, okay? Oh, wow, check this out. So we had 15 inches over there. What's our height here? Let's go from 0.
I'm not touching it.
Wow. So on that side, what are we reading so far?
It's literally.
What's the top right?
What's the very,
right
very
here.
top?
What's the top of that?
If that's 35, what would the very end be, do you think? Yeah. Oh gosh, it doesn't measure high enough. What do we do? What can we do to solve that problem?
She wants to.
All right, so 36 plus. So how high? What do we do here? Gosh, 36. All the way up to 8. 36 plus 8. Wow. So do you think? So tell us about your base.
First, I put 4 straws and I taped them together. 2 straws. Yeah, 2 straws, 2 straws, 2 straws. And then we stacked it up, but then it didn't work. So then we were like, what can we do? And then she thought, let's do it like a campfire. Yeah. And then we started building up.
So we're at 44 inches. Do you think that when we come back it can be even taller?
Yeah.
All right.
Okay,
you
I
got it.
think we have time for one more.
All right. So they were at 44. Holy cow. Here's 36. And then 12 more. Holy cow. So does it stand up though?
It's like falling.
Well, let's see.
Okay, so
What's
step
part of
one.
it?
It's gonna fall.
All right, so we have an incredibly tall structure that does not stand up. So you need to work on getting it to stand up, right?
Yes, we don't have any more tape, so it's hard.
Ah, well, maybe there's a way that you can go not quite as high, but it still be sturdy. We'll come back and check on you. So how's it going over here? Oh, we're starting over. Okay, so tell us about what you have going down there.
So we're gonna make a square and then we're gonna make it go up.
All right, and so tell me a little bit about why you've decided to start there.
I know how to do this.
What did you learn from your first iteration, your first try?
Wasting a little more straws than we needed.
Oh, okay. Yeah, I noticed earlier you had a lot of tape that you were using in your base and you were running out of tape, right? So maybe this will be more efficient, maybe sturdier? All right, so we'll come back and check on it.
Okay, so let's make it up.
Look at this, we have a freestanding structure. Do you think it's taller than 36 inches? What do you think?
It's almost.
It's,
We want to get an idea of how to make it taller.
all right, so you're at about 35 inches right now. And the tallest tower so far is 44. So do you have some ideas about how you might go taller?
Our idea is like we would like add on to more of these and then like make a second place and then like add on.
Yeah, you guys are having an amazing project so far.
Well, as they continue to work, so far we have 2 successful towers standing on their own.
And a few who are on their way.
Yes.
Getting close.
So we're going to send it back to the studio as they continue to work on their towers.
All right, nice to see that we had a couple of them standing on their own right there, and some others that will be modified as we continue to go along. In studio, we have 6th grade student Elizabeth with us, working on some equations and some percentage problems before. Now for something completely different. So I'll read the problem, and then you guys can go ahead and work on this. As Molly's mother was waiting for Molly to return from trick-or-treating. When you go out do you go out trick-or-treating? Mm-hmm. How long do you go out? Like 4 hours?
Not that
Like 7 to 11 you go out? Like an hour maybe? Or
Maybe 2 hours.
2 hours? All right. She started looking at the nutrition information on the bag of candy she was distributing. Probably not a good idea if you're trying to help kids.
It's a downhill
For this bag of candy bars, a serving size is equivalent to 4 candy bars. There are 8 servings per bag and 200 calories per serving. According to the information, how many calories are in 1 candy bar and how many calories are in all of the candy bars? So that's why I need you to figure out how many calories are in 1 candy bar and how many calories are in the entire bag. So you and Scott can go ahead and get to work.
All I can
Okay,
say
before we
is
write anything down, go ahead, tell me what you're thinking. I'm sorry.
too much. Too many.
So that's one question, right? 1 candy bar, we need to know how many calories in that. And we also want to know how many calories in the whole bag, right? Was that the other question? Is that right?
Yeah.
Okay. So what are you thinking? How do you want to go about finding out how many calories are in 1 candy bar?
First, I need to know how many candy bars are in a bag. So
How many-
I would
okay.
multiply 8 times 4.
Okay. Gotcha. So we have 32 candy bars in the whole entire bag.
Yep.
That's definitely going to be some good information. Just doesn't answer either one of these questions yet. So what do you want to go from there? What do you want to do with that?
From there, we need to figure out how many calories are in the bag.
What about in 1 candy bar, though? Because if you knew how much was in 1, then you can multiply it times 32 and figure out how many in the total bag, right? But we still need to get back to 1. We know that there are 200 calories in 1 serving, right?
I think I would do 200 divided by 4
And why is that?
because there are 200 calories in 1 serving and there are 4 candy bars in 1 serving.
There you go. That's right. So if you put that 4 basically down there, right? 200 divided by 4. Good. Okay. 50 what?
50 calories per candy bar.
Good. Have we answered one of our questions yet? Go for it. 50 calories per candy bar. Okay. So if you only ate 1, no big deal, right? We're looking okay. However, if you just had one of those days and you wanted to eat the whole bag, how many calories would you consume? That's what we want to figure out now, right? All right. What are you going to do next?
50
50.
times 32.
Ah, there you go. Okay, there's the problem. Got a little bit of multiplication to do there. Good. Got to add those two together. 0, 0, 6, 1. What number is that?
1,600.
That's like a whole meal. Who needs regular old food? We just have a whole bag full of candy bars. Nice job. 1,600 calories for the entire bag. What do you think? How many candy bars could you eat sitting down all at once?
Probably
they're
3.
Nestle Crunch, probably a lot, right?
That's
Her
right.
favorite
Depends
one.
on what they are.
So anyway, 1,600 calories is a lot. I think, isn't it 2,000 calories for a
For the day.
for the day?
Yep, that's the
All right.
recommended. That's
Well, you
they
know
say.
what? Excellent work on that. Erase the board. I've got another one for you.
Okay.
Speaking of time, this one has exactly to do with time.
All right.
All right. Molly was allowed to trick or treat from 6:30 p.m. until 8:45 p.m. if she averaged visiting 2 houses every 9 minutes.
Ooh.
How many houses did she visit?
Really interesting problem. Okay, Elizabeth, where are we going to head with this problem? First of all,
We need to figure out how long it takes to get to one house.
okay, I like that. Let's do that.
So we would have to do 9 divided by 2.
Okay, 9 divided by 2. So 4 times 2 is 8. You got 1. Ah, you add the 0 there because we weren't quite even yet. Good idea. So if you want to go to one house, how long is that going to take you on average?
4.5 minutes.
4.5 minutes. Okay. All right, so what's next? We know how long it takes to get to one house. We would like to know how many houses she got to, right? So how long was she trick-or-treating, which was the question you got asked earlier.
I think we need to figure out 845 divided by 4.5.
We could do that. However, we just don't know how long she's actually been out, because 8:45 would be 8 hours and 45 minutes, right? She wouldn't have that long.
845 minus 6.
Let's do that first. Okay, good idea. There you go. So we're going to do 8:45 minus 6:30, and that should be able to tell us how much time she was actually out collecting free candy.
2 hours and 15 minutes.
2 hours and 15 minutes. Is that enough time to collect enough candy? Is that enough time to fill us a pillowcase? I know that's what the main thing is, to fill a pillowcase. All right, 2 hours and 15 minutes.
Now, I'm going to bring up another thing, okay?
Okay.
Just like the candy corn, right? The pillowcase is something we used to use also. Do you guys use pillowcases?
I use a regular bag.
Yeah, it's your regular bag, right?
I go
think
pillowcase.
Pillowcases went away with our time also.
Yeah, maybe
you know,
that's
something
it.
like
Yeah,
that.
you got to put on the running shoes and get to as many houses as possible and fill that
That's right.
pillowcase.
I'll hit a house every 1 minute. Go.
I've seen people use pillowcases.
Yeah.
You can get a lot in there. All right, continue with the problem.
Okay, so 2:15. Tell me about 2:15.
Well, we can make that into 2 and 15.
Okay, it's 2. Well, I'm still going to keep this one here for a reason, that it's because it's time, right? But tell me, it's not 2:15 like in the afternoon. What does this represent?
It represents how long we can trick or treat.
Okay, and tell me how long it is.
2 hours and 15 minutes.
Gotcha. 2 hours. And when you say and, it's kind of like plus, right? 15 minutes. It might be a good idea for us to figure out how many minutes it is, because we know that you can go to one house every 4.5 minutes. But if we have hours and minutes together, that might not work out so well. So how can we make 2 hours and 15 minutes all into minutes?
Because 1 hour equals 60 minutes,
Okay.
we would do 60 times 2,
Okay.
which is 120.
So we have 120 minutes. And then what about this part?
And with the 15, we would divide 120 divided by 15.
Well, what's the sign here?
Oh, plus
There you go.
15.
So add the 15 on the end to the 120. So we have 120. It's kind of like this is 120, and we're adding in 15, right? So can we add those together?
Yes.
Oh, a little work in the head there. Okay, so if we're going to go trick-or-treating for 135 minutes, and we hit one house every 4.5 minutes, we've simplified this problem. Now I think we can figure out how many houses to go to. What's our last step here to be able to figure out how many houses?
Divide 135 divided by 4.5.
Ah, I'm really glad you went back to the decimal on that, because we had a decimal in the problem. You went to 4.5, which makes sense. That's kind of how we would say it, about 4.5 minutes. But then you went back to a decimal here when you're dividing. I think that's a good choice. How are you going to start that problem, that division problem there?
We can't have a decimal, so we have to move that 10 places up, which means we have to add that 10 places.
Gotcha. So you move both decimals to the right. Good start.
And then we have to do 45 divided by 130. 1,350.
Wow.
Would you like to use a tool? You have a tool over here, you know, you can use.
Sure.
It is Halloween week, and he's not giving out candy bars, but he is giving out some tricks apparently. So we can use a little trick here.
You have 1 minute to solve this problem, so I just want to help you along with this.
So 4 into 135. 45 into 135, and then add a 0, right? So it's going to have a 0 on the end. There you go. 30 houses is what we came up with. Let's see. Do you think you can get enough candy with 30 houses? I guess it depends on what they're giving out, right? As long as they're giving out some good crunch bars and none of that candy corn, we can be okay.
If you're going out late at night, then they just give you the whole bag.
That's right. It depends on how much they want to close up shop. I got to find those places that are closing up shop. Hey, are you shutting it down? Okay, I'll be your last customer. Pour it all in here.
There you go. Nicely done, Elizabeth. Great work right there. And for some excellent work today, we're going to award you with a meal courtesy of our friends at Broken Yoke. So, congratulations on that. Hey, we do have phone tutors available until 5:30, but we also have one more opportunity to go see how the kids are doing at Loudon and the Science for Kern.
We are back at Loudon Elementary, and again, I'm with Michelle Roy, Science for Kern and Engineering, and we are at the
Final measure off point. We've had some really interesting things going on in the room today.
We have. They've been exploring. They've been changing up what they want to do.
A lot of discussion around, I think the hardest part of the challenge today was the wise use of tape.
Yes. I agree.
Most of the groups have discovered that they over-taped in the beginning, and so here at the end, in order to go up, they need more tape.
And again, they only had
1 meter.
1 meter of tape.
1 meter of tape. So anyway, it's been fun to watch, but let's measure.
All right, let's get started.
All
Where
right,
should we
so
start?
girls, we're going to start with you.
I don't think it stands up.
You have an amazing tower there, but is it freestanding?
I don't know, but.
What happens if we let it go?
No, leave it. That wasn't on there.
So how tall, will that stand?
Stop. Leave it. Leave it. Yes. Let go. Let go.
All right. Oh, I'll let it go. Oh, 1, 2, 3. Oh, whoa.
You added stuff. Wait.
All right, will that stand? Oh, but that does. Ta-da! Right, way to go.
So you added
So how tall? It looks like, I think you're taller than 36 inches. 36 inches and then some. Grab the ruler there. Let's go a little, we got to measure just a little bit more.
There we go.
So 36 plus, let's see here, 37, 38, 39, 40, like 41 inches tall? Ooh, high five. So tell us a little bit about your design.
So like.
Why the triangle base? That's unique to your tower.
So like we used 3 straws and then we did like 3 straws right here, but we used 2 because he was falling.
And so the 2 straws serves what purpose?
It helped it more stand with like that much straws. And then we kept using like 2 until we got up to there.
Check it out. Okay, so we got single straws up as it got taller. Well, congratulations, ladies.
Thank you.
How tall did we say we were here? How many inches? 41 inches. All right, let's see. You guys might have be the winners of the challenge. All right, so how many inches do we have here, ladies? Because you had to start over, right?
Yeah.
What happened?
Because we were using too much tape. Too much tape and straws.
See, we were talking about the wise use of tape. So, you guys think you beat 41 inches?
No.
Well, let's see how tall we are here.
Not that tall.
So how many inches?
8.
8 inches. So then if you were to continue to go up, what's your plan?
We were just keep on going and putting it up.
In this cube
No.
shape?
Put the straws. It's like a house, but like put straws over it and then like stack the straws up.
So roof shape next, and then after you have a roof shape, then how will you go up?
We you will it will have like a circle, like a middle where you can like put straws in it to go up.
Do you think you would have enough tape? Yes.
Are you out of tape now, or did you have more? I don't see any tape left. Oh, you have a few tiny pieces.
But
To make it more secure.
we wouldn't put. We'll put tape like for the we'll put tape like 4 tapes right here, and then like put it all together, and then leave a hole, and then like put the straws inside the other straw.
Okay. Excellent.
Nice job.
Well done, ladies. All right, so what do we have here, gentlemen?
We're still fixing it.
Okay, so do you have a freestanding structure?
We don't know yet.
All right, well, let's test it. Put it out there and see if you can, because this is the structure that the base wants to squish in on itself, right? So what if you take it down? What if we modify the height? Will it stand up if it's not quite so tall?
I think it's taped. Let's try.
Will that stand up?
I don't think so.
Because the record. Well, what happens if you open up the base a bit
I think it will.
without it coming apart?
Why don't we have them you guys keep
keep
working?
working. We'll be
Okay,
back.
you're doing a great job. Keep working on it.
Come back for a measurement. Oh, we have a freestanding structure. All right, so 41 inches over there. You guys want to help me measure?
Yeah.
All right, so here we're at 35. Let's see. Look at that. 35. Do we have 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Now let it go though. And let's see.
I would say that's another, 2 inches?
Maybe 2 more inches. What do you gals think? To go that.
Yeah, 2 inches.
So what shall we call this? How tall?
51.
or 50.
51 or 50.
Sounds like a winner to me. So check out this base. Talk us through a little bit of what you were thinking when you designed that base. That's quite unique.
So what we were thinking
is that we connected 2 straws here, then we put tape. Then we decided to make this like a campfire design. Then we started working our way up.
So how does this this 90-degree base with the campfire design, how do they work together?
It works together by how like they connect and how it holds the tower.
Okay. So without this part, would you have a freestanding structure?
We think.
You haven't tried that? Okay. Because it looks to me like maybe this base down here is keeping your campfire design part open. But well done, ladies.
Nice job.
All right. So what happens if you let it go? Oh! All right, so we have a nice tall structure, but it's not freestanding. So tell us a little bit about your thinking, though, in terms of the base, though, because it looks like you do have a nice, solid base.
So at first we had like a triangle, but then it kind of broke down.
Okay, and
So
why
we
a
had-
triangle?
Because it was like more stable on the ends.
The triangle. So lay a straw on to demonstrate what you mean by triangle.
It was like this.
Oh, up like that. Sort of similar to what the girls are calling over there their campfire design to stabilize it.
Well-
All right, nicely done.
Yes, we've had some amazing structures today. Did you guys have fun doing your structures?
Yeah, way to go. So we had an over about 50 inches.
And then we had
And then second
41.
place there at 41.
Great
well
job.
done. And some that maybe with 30 more minutes and a lot more tape, we'd
Yes.
probably have even greater success.
We would. Well, thank you again for another fun lesson for Science for Kern and Engineering. And that's it today from Loudon Elementary School. Back to you at the studio.
As they put in that site, and there we go. The kids working at Loudon right there, and as we put in the site right there.
That's it.
So anyway, in studio with us today, we had Elizabeth, a 6th grade student, and you know what you now are? Smarter. I'm only
right.
kidding. I'm only kidding. You've been smart the whole time. But you have a lovely blue shirt, and we're going to replace it with another lovely blue shirt. This now means you are an ambassador for Do the Math. Do you have any idea what that means?
No.
Okay, that means you need to tell other kids about Do the Math. All right? So you wear this to school or something like that, and people go, hey, what's up with that shirt? What is that? You can just tell them kind of what it is, TV show, help you out, do math, things like that. You can do that?
Yep.
All right? Can you do it every day? Wear this every day?
No.
All right, that's fine. I don't need you wearing it every day. I'm sure your parents won't like that either, all right? But anyway, you did a little bit of work with equations, percents, some multiplication,
A lot of candy.
figuring out all sorts of things with Halloween and things like that. So did you have fun?
Yep.
All right, good. That's the main idea right there. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays, as we do today. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.